So it's just like a real floppy, glidey joint. And you saw the surfaces under there, they're real smooth. So you can get like a real sliding motion between them. The joint is designed to move very smoothly. However, there are very few people in this world that move smoothly at this joint, and I wonder why. It's probably because, or at least partially inhibited by the fact that these obliquous muscles are tight on practically everybody. So if this one were to rotate right and then to stay rotated, you know, then this one, no matter how hard it pulled, couldn't pull you back. And then you'd have to get rotation from the, if you wanted to rotate your head, then you'd have to get it from the joints below here, which are stickier and gummier because they have that those discs between them. And you have these kind of more blunt muscles. You don't have the very lithe and specially designed obliquous to turn them anymore. Okay, so normal motion of the head is 45 degrees just from the obliquous muscles. 45 degrees either way. If the head goes farther from 45 to 90, it has to have the help of the splenius capitis on the back of the head. It has to have the help of the rest of the joints opening in the rest of the facets, and also the sternocleidomastoid on the front of the neck would help to pull the left ear around forward. So the normal range of motion of a head is 90 degrees. There are very few people that can rotate 90 degrees, and that's why we need to learn this, because of the people I see, this is the chief malady that most people are suffering with, is they can't rotate their head all the way. They got some kind of kink in their neck. Okay, that's normal motion of the neck. Now let's talk about an abnormality that happens in probably 1 out of every 30 people I see. I'm going to change this over. This is no longer going to be the splenius capitis. It's going to be the sternocleidomastoid that's going around the front. And I'm going to have it come out of this side here so I can give her a pull. Both the splenius capitis and the sternocleidomastoid are kind of mirror muscles of each other. They both attach to the mastoid process right here. Okay, so we still have the splenius capitis on the left showing here, the SCM on the right showing here, which I'm pulling from down here. It attaches down to the clavicle, which is right about here. Okay, so the person's looking straight ahead. Let's say the person uses, as normal, their obliquous inferiors to rotate their head left and right a few times, and something bad happens, like, oh my goodness, I've had bad news, I have to clamp my neck up. So now if both of these are tight, it's much harder, it's a much jerkier motion to move left and right. And if both of them are contracting, then you can't even get that first 45 degrees of rotation at all. So this happens in quite a few people, that both of them are so tight that you can't get any rotation from above, and so all the rotation of the neck, you only get about 45 going each way, and it's clunky, it's jerky, because it's all coming from the joints below C2. It's coming from those facets opening as the rest of these move, and with bigger muscles causing that to happen. So that's one potentially tight situation we'll see in probably 50% of the population, that both of these are tight. They both need to relax to some degree. You see I'm kind of clicking them because they're kind of like guitar strings at this point. So neither one will move. Now what if just one of them is spasmed, and so it gets pulled over into this tightened position, and then it refuses to let go. So to demonstrate that, I'm going to actually tie it in a knot here. That is tight. The person is looking to the right, and this is in spasm. Their right obliquous inferior is in spasm. And no matter how much you pull on the left one, that is not going to move back. So What does the person do? Do they walk around all day long just looking to the right? No. Their brain, other parts of their brain, even though the hindbrain, the cerebellum, has determined I need to guard this, I'm not safe, I need to protect my neck here. The rest of the brain doesn't agree with that command, and so it says, yeah, but I need to look forward. And so the more mid and forebrain will use different methods to contract the sternocleidomastoid on the right and the splenius capitis on the left. So what happens when I pull on both of these? Yeah, we can get that head to move back. Okay, the head has now moved into looking straight ahead. But at what cost? As soon as I let go, the head will move right again. So I have to keep these in constant tension. So I'm going to hold these in tension, and hear that note? That is tight over there. The left splenius capitis is very tight. You could massage this left splenius capitis all day and it's not going to cure the problem because it's the right obliquus that's the problem. How do you know this? How do you find it out? Well, because you run your fingers along the back of the spine here and you feel that, whoa, look at that. That spinous process is way off to the right compared with a straight line down the back of the spine and a straight line up the back of the occiput right here. Can you see that well? I'm going to put a straight line here. This is where the, oh, my knot is coming out. This is where the back of the head is. And this is a straight line down to, from the back of the head to C7. We'll go like this. And do you see how the spinous process of C2 is way off from a straight line there? So you can see this visually if the person is face down in a face cradle, or you can feel it while they're face down, or you can feel it while they're face up. So that's just one way of assessing. We have other ways of assessing it as well. So we got a very tight muscle over here, twanging, and we got a very tight muscle here, and we got a very tight sternocleidomastoid here. And our ranges of motion are going to be like maybe can go a little ways to the right, but can't go to the left at all. It just can't afford to go any farther to the left. It's already gone to the left as far as it can. It's already taken up all the slack going to the left from these lower joints. It can't go to the left any further because this right obliquus will not relax. So this person will have 0 range of motion to the left and 45 going to the right. Okay, so what's the cure for this? We have to, we've already figured out that because the spinous process is going over to the right, it must be this right obliquus, and also the range of motion told us. So now we know it's the right obliquus. So we just come over here and start hammering on it. It's just going to get irritated and tighten up all the more. What we have to do is get it into an even more shortened position. So we'll rotate the head this way even more until, see how the slack has come off there? And then if we massage it while it's in its shortened position, then it's going, okay, there's no tension on me now. Maybe it is safe to relax. So if we tried to massage it while there's tension on it or tried to stretch it, it's just going to get more ornery. But if we move it into a shortened position by rotating the head this way, then see how soft and floppy that is? It's going to go, sure, I feel safe to relax. And so, voila, while you're pressing it in its shortened position, ta-da, the stress comes off. And then you feel like, whoa, that head wants to come back to neutral now. It comes back on its own accord. You didn't have to push this bone over. You didn't have to use any force. It just came back on its own accord because the ligaments want it to be straight. You don't have to push C2 back. You don't have to do any kind of a... You don't have to use any force. It will come back on its own as soon as the tension comes off of this muscle. And then we're happy again. Yay! Look at how smooth we are. End of take 2.